Okay, so I chose to do my reassessment on the original test question. So first we start by drawing a free model diagram. This is our force in question, our force unknown, we'll say, and it's the force that is pushing the book against the wall. Then we have our frictional force, our normal force, and our weight, which is mass times gravity. Our mass times gravity is going to be, our gravity in general is going to be our long range force, and then frictional force and normal force are contact forces. We're going to write down all the forces acting on the mass in both the x and y directions. So we take all the x's, this is our sum of x equation, which is equal to 0 because the object's not moving. So we have the normal force, and then part of our force unknown that is in the x direction. So we put that as sine theta. Even though we know what the angle is, we're just going to leave that till the end, which is equal to 0. Then we also take our y. So we have our frictional force, our weight, and then our force unknown with cosine, which is this piece. So first we're going to get our frictional force equation, which is mu s, static force, which means it doesn't move, times normal force. So we're going to sub that in into our y equation. Our y equation. So we have our frictional force minus gravity plus our force unknown and cosine theta equal to 0. We rearrange to get n by itself because we're going to end up subbing in the sum of x equation. So we have the normal force equals the weight minus force unknown cosine divided by mu. And then now that we have n by itself, we can now sub out n in our sum of x equation, which is going to be mg minus force unknown cosine divided by mu minus the force sine theta equal to 0. We can rearrange that to get f sine by itself by simply rotating to get rid of the negative in front of our force unknown sign. We just move the force sign, basically just flip it around. We're going to rearrange to get our unknown by itself to be solved. So we're working this all around, and basically what you want to end up with is being able to pull out your force unknown from the sine and cosine. Once you've gotten there, you've pretty much done everything else, and then it's basically dividing your weight by mu sine theta plus cosine theta. And once we've gotten there, we can put in our numbers, which is really easy, which allows us to get our answer 15.8 newtons. And 15.8 newtons is the minimum force we need to keep the book from moving.